Hello student, again coming back to chapter number 13, that is organism and population. In this class we will discuss about adaptation. Okay, so adaptation se kari haibano hataragadi actually it is the ability of the organism that enable them to survive and reproduce in its habitat. Haibadi nasai organism sina ano habitat am lakanda haiba ano habitat to gi environmental condition that adjust tawdana reproduce tawdana adra survive tawngambado akoni kaigona we call it what adaptation. And here we will discuss some example of adaptation related to plants and animal in different habitat one by one. Okay, so first come to adaptation of plant to scarcity of water, and here we will take the example of plant xerophytic plant, that is opuntia. And opuntia se kana cactus ni ko arsigi cactus na ising yam tana leba jaga da ising yam leitaba jaga da kamain torok adapt tawba ngamge habedo adu ngamna ba monot kei cacti yo habedo adu discuss ausi. So opuntia have thick cuticles. They have second stomata, and the stomata remain closed during daytime just to prevent transpiration, and they usually open during nighttime. In addition to this, the leaves are also modified into spine just to reduce transpiration, and stem are also modified to perform photosynthesis. And this opuntia, they also perform a special type of photosynthesis that is known as what? CAM pathway, that is carcinogen acid metabolism. So these are different characters which are present in opuntia so that opuntia can easily adapt to those areas where there is scarcity of water. Next come to adaptation of animal to scarcity of water. For this, let's take the example of kangaroo rat. Sigi kangaroo rat which is found in desert. Sigi kangaroo rat se kamain toroga desert ta ngasagi ising yam leitaba jaga dura kamain toroga survive tongamino habido adugi magi adaptive features indo discuss ausi. So this kangaroo rat can reduce water loss. Not only that, they can also tolerate hot condition. Aduga sigi kangaroo sina daka taiba water do kaide loge kana from fat oxidation. During fat oxidation, definitely water will be released, and this water can be used by kangaroo rat. Okay. Not only this, they can also minimize water loss by producing nearly solid urine as well as what fecal matter. And in addition to this, they have thick skin, okay, or thick coat to minimize water loss. So these are different characters which are present in kangaroo rat so that they can easily adapt to those areas where there is scarcity of water. Next come to adaptation to cold. First, let us discuss about Allen's rule. The hari se kena kanda principle amane kari principle kanda sida organism kharadi kadoke kanda my body gi size body part khargi size se reduce over tare sina kam kana ge kanda magi body de manga da heat loss so hanhan kena kanda body size sa tar gadi heat loss to yam yam ko dene na body size pitha laga heat loss obodo hanhan mani aduga nasai aing jaga do ilaina adapt to gam tare. That is Allen's rule. It is a principle that describes that some animal will undergo changes like having short ear, short limb, so that heat loss can be reduced. Next, come to another point related to adaptation to cold. So mammal like seal, they have thick layer of fat below their skin, and this thick layer of fat they function as what? Insulator, and thus it reduces the loss of body heat. Okay, thus aquatic mammals like seal can easily survive in polar region. Aduna seal gumba akwai ka polar region leba akwai mammal se migrant da mai skin ni makhasida thick layer of fat am yauriba ana sine ka dore insulator and egg toraga my body heat to manghande aduna ka dore seal gumba mammals se they can easily survive in polar region. Next come to phenotypic adaptation. Here, some organisms have phenotypic adaptation which allow them to respond quickly to any kind of unfavorable situation. Haibadi organism kharadadi magi phenotypic character changes la aga my habitat la any unfavorable condition do adura response toroga ilaina adapt to ngame. So to understand this, let us take one simple example. So, while visiting high altitude like Rotang Pass near Manali, Mansarovar in Tibet, definitely we will experience a condition which is known as altitude sickness. This is because at high altitude there will be low atmospheric pressure and less oxygen. Haibadi high altitude adi sayilba atmospheric pressure handarani aduga oxygen concentration handarabanina akoina condition ama thenarakani habaneba adui condition okay we call it what? Altitude sickness. Okay. And symptoms of altitude sickness are nausea, oningba, fatigue, hasang soktaba, and increase in heartbeat as well as what? Shortness of breath. and this symptom usually come within 12 to 24 hours of reaching high altitude. ado sigi pose ai body na ilai adjust togidene kumaina having siko, that means our body will get acclimatized and will stop experiencing altitude sickness, because our body will compensate low oxygen availability by increasing what RBC production, because this RBC it contain hemoglobin and it will carry what oxygen, and there will be decrease in binding capacity of hemoglobin and by increasing what breathing rate. Agi bodies na ngasagi altitude sickness experience obodo kumain to overcome toge hai kanda ngasagi agi bodies kadoni RBC production hengala ani aduga hemoglobin ga oxygen gi binding affinity handarani aduga agi breathing rate se hengala ne. So this is about phenotypic adaptation.